Hello, good morning, children. Welcome to 7th Standard Science class, Physics, Chapter-5, Heat, Part-3. In last class, that is in Part-1 and Part-2, we learnt about heat, effects of heat, measurement of heat, thermometer, reading of thermometer, and at last we discussed about digital thermometer, right? If anyone didn't watch the part 1 and part 2 of this chapter, first you watch it, then only you will understand remaining topics of this chapter, okay? Let's move on to the next topic, that is transfer of heat. Children, you know that heat travels from one place to another place, right? As we already learned that heat energy is always transferred from a hot body to cold body. For example, when one end of the rod is put in a flame, okay, here one end of the rod is put in a flame, then its other end also soon becomes very hot. Why you know? Yes, you already know that heat energy is always travel from hot body to cold body, right? In this case, here heat energy travels from hot end to the cold end. This part is hot and this part is cold, right, compared to this part. So here heat travels from this hot part to the cold part. That's why we feel very hot. Got it? And in next case, here you see a glass of hot water is left on a table for some times, then water becomes lukewarm or moderately warm. Why you know? Here also heat energy from the hot water is going to transfer to the surrounding. That's why here hot water loses energy to the surrounding. Then it becomes moderately warm. Got it? And in third case, here you see metal chair is left out in a sun during summer. It becomes too hot. Right or no? Here during summer when you left a metal chair, then it will become too hot. Why you know? Because here the energy from the sun, heat energy from the sun, it is transferred to the chair, metal chair. Got it? So here what you observe, in all these cases, hot object losing some of its heat and cold object gaining the heat. Like this, transfer of heat takes place. Therefore, we can say that heat energy always transfer from hot object to the cold object. Understood? Yes. Children, in nature, there are three different methods of transfer of heat. They are conduction, convection and radiation. Understood? Here, in nature, heat transfer in three different methods. That is conduction, convection and radiation. Let us learn one by one in brief. First, we will learn about conduction. What is conduction here? Well, you have seen that food gets cooked in a pan when it is placed over a flame or burner. The food in the pan becomes hot and after some time it started to boil, right? How this happens? Well, here this happens because heat burner is transferred to the pan. Got it? Here heat from a burner is transferred to the pan and this process what we call conduction. Got it? So the flow of heat through a solid is known as a conduction. Conduction is the most significant method of transfer of heat in solid. Then when this conduction happens? Well, here conduction happens when two substances with a different temperature come in contact with each other. Understood? What are the necessary conditions for conduction? Well, here the first condition is that whenever in order to transfer heat from one object to another object by the conduction method, here for example this is object 1 and this is object 2. The first condition is two objects should be contact with each other. Understood? Here the two objects should contact with each other. And second condition, there is a temperature difference between these two objects. Means the first object having a temperature of 10 degrees Celsius and second object having a temperature of 20 degrees Celsius. Means there is a temperature difference between object 1 and object 2, right? Then only the conduction is going to be takes place. For example, if the temperature difference between two objects is here, the first object also 10 degrees Celsius, second object also 10 degrees Celsius, means there is no conduction of heat from one object to another object. Got it? Understood? Well, then how this conduction happens? Here in this method, how heat is transferred? Well, here in this method, heat is transferred from one particle of the object to the next particle of that same object without the particles leaving their places. For example, you just considered iron rod. Children, as I already told you, each and every matter in the universe is made up of small particles, right? Here also this iron rod is made up of small particle. As I already told you, when you eat one end of this iron rod, then its other end soon becomes very hot. How this happens? Who transfer energy from this part to this part? Have you any idea? No, right? Well, here you see, when this part of this iron rod heated, then the particles which are present in this iron rod also get heated up, means they also gain heat energy. Understood? When you eat this part, the particles which are present in the iron rod gains heat energy. Then what they will do then? Here, when they gain heat energy, they simply transfer this heat energy to the neighboring particle. Here I am heating, only this much part I am heating. This much part particles gain heat energy. So when these particles gained heat energy, that heat energy is going to be transferred to the neighboring particle. So here this neighboring particle gain heat energy now. So when this neighboring particles have heat energy, they simply transfer this heat energy to the neighboring particle. Understood? Got it? So here first these particles have heat energy, so they transfer simply to the neighboring particle. When this particle get heat energy, this particle gets transferred this heat energy to the neighboring particle. Like this, heat energy is transferred from one particle to another particle. Understood? So at the end, you are going to reach the heat energy. So without particles are traveling, here particles are not traveling here. They simply vibrate on their mean position. They simply transfers the heat energy from one particle to, see this particle is it is here only. It is not travels to here in this place. Okay. It is going to be at the same place only, but it simply transfers this heat energy to the neighboring particle like this. Understood? So here heat energy is transferred from one particle to another particle. So without particles traveling from one place to another place, they simply transfer the energy from one particle to another particle. Understood? Here particles just vibrate about their mean position and keep on passing heat energy to the neighboring particle. That's why its other end soon becomes very hot when you eat this end. Understood? Got it? How this energy is transferred? Here energy is transferred mainly the particles which are present in the matter. Okay, they simply just pass the energy from one particle to another particle. Got it? Understood? Now let us perform an activity to understand the method of conduction. For this activity, we require a metal rod, melted wax, small buttons, metal stands and candle. In the first step, take a metal rod. Okay, in the first step, take a metal rod. Okay, here I taken metal rod. Wait. Yes, here I taken a metal rod and coat this metal rod with a thick layer of wax. Here wax is in liquid state. Okay, it is a melted wax, right? It is in liquid state. Here I will just coat this wax on this metal rod. You just coat it properly. Okay. Yes. Here I coated wax on the metal rod. After coating properly, then you fix small buttons onto this wax. Here buttons, the shirt buttons. Okay. Here I am using the shirt buttons. Just fix the small buttons on the wax. Here I am fixing some small buttons. It will fix because it is in, this wax is in liquid state now. It is easily fixed onto this wax. Okay. Fix some small buttons on the wax. Here buttons are placed at equal distance. Okay, you just keep it in mind. Here buttons are placed at equal distance. Means here I exactly placed at equal distance. That exactly 5 cm difference between these two buttons here. Okay, 5 cm distance wise I just placed. Got it? And allow wax to solidify. Here after fixing, it is in liquid melted wax, right? Just leave for some time to solidify so that it becomes hard. And next, fix this rod on to metal stand. Here you see, fix this rod on to metal stand. Understood? And then light the candle and place it at any end of this rod. Here the candle is placed at this end. You just look at here, right? Then after some time, what you will observe here? After some time, here we will observe that when this end of the rod gets heated up, the particles which are present in the rod start to transfer the heat energy from one particle to another particle, right? So the heat energy is going to transfer from one particle to another particle. So when it reaches this wax, right, initially it was solidified. When the heat reaches to this wax, then wax gets melt. Then whatever the buttons attached to the wax starts to falling down, right or no? Here you need to notice this point. All the buttons are not fall at a time. Here buttons are falling one by one. Just look at here. Why this happens? Here because heat energy transfer from particle to particle, right? So first heat energy transfer to this part. When the heat energy is going to be melt the wax, then the buttons start to fall, and then the heat energy transferred from the neighboring particles. So like this, heat energy transferred from particle to particle. So here along the transformation of heat from one part to another part, then the wax get melts and buttons which are attached to the wax also starts to falling down. Understood? Got it? Children, let me ask you one question. Is heat energy able to pass easily through all solids? Well, heat energy is not passed through all solids. Here, some solids, especially metals, allows the heat energy to pass through them easily. For example, here you see aluminium, copper, iron or some of the metals, they allow heat energy through them. Understood? That's why these are all called conductors, because they are good conductors of electricity. Understood? What are conductors? The conductors which allow heat to pass through them easily, for them what we call conductors. But some solids, they do not allow heat energy to pass through them. For example, here you see plastic, wood, glass. These are also solids, they do not allow heat energy to pass through them. And these are what we call, insulators. Means here they do not allow heat to pass through them easily. Such a solids what we call insulators. For example, here you just take a wooden rod, okay, you just heat up the wooden rod at one end, then here its other end you are not going to feel any hot even after a long time. Thus wood is a bad conductor of heat. In case of iron rod or metal rod, when you heat one of its end, then its other end becomes hot, right or no? But in case of wooden rod, when you heat one end of this but other end does not become hot. Due to this, wood is a bad conductor of heat and also known as insulators. Got it? Understood? Yes. But children, both good conductors and bad conductors have many uses in our daily life. Understood? Here insulators are bad conductors, right? They do not conduct heat energy. But here both good conductors and bad conductors have many uses in our daily life. We will see some of the uses of these bad and good conductors. Okay. First, here you see we use metals to make cooking utensils because metals are good conductors of heat and they quickly transfer the heat of flame to the food which is kept inside the utensil. Metals are also used for kettles, boilers, etc. Due to this, good conductors of heat. Understood? They are called what? Good conductors of heat. Understood? Yes. And even you see wooden or plastic as used as a handles for holding tea kettles, cooking utensils. Even though they are bad conductors of heat, we have applications in our daily life where we are going to use exactly they used as a handles for holding tea kettles, cooking utensils. You already know this, right? Here these wooden or plastic handles help us to hold them even utensils are quite hard. This is because wood and plastic is insulated, means they do not allow heat to pass through them easily. So they do not let the heat to get transferred to our hands. Understood? And next, for making house, we use bricks and mud, right? Then how they help us? Here, bricks shields us from heat of the sun during summer. This is because bricks and mud are bad conductors of heat. So they do not allow the heat of the sun to reach easily inside the house. But rooms which have a tin roofs. Here you see, the rooms which have a tin roofs often very hot during summer because here tin is a good conductor of heat. They allow heat of the sun to reach inside the house easily. Got it? That's why during summer, the rooms which have tin roofs very hot. Understood? Children, you know, air is a bad conductor of heat. Because of this property, blankets and woolen cloths help us to stay warm in winter. This is because here you see blankets and woolen cloths trap air between them. And you know, air is a bad conductor of heat. So, whenever heat which is coming from the body also trapped, because here air between the woolen cloth does not allow heat to transfer the heat into the surrounding. So our body heat does not easily escape out through this trapped air and we stay warm. And one more application is that ice is kept in a double wall container. Why you know? This is because to prevent the melting of ice. Then how this ice box prevents melting of ice? Well, children, here due to the double wall container of this ice box, a layer of air is trapped between these two walls. Layer of air is trapped between these two walls, and you know air is a bad conductor of heat. Hence, it does not easily allow outside heat to reach ice kept inside the box. Thus, ice does not melt quickly. Got it? Understood?